Now there are new ways to make vaccines. And that's why there's been this race. And there's 44, I believe, active trials of vaccines. And there are four major categories of vaccines. Okay. First strategy that's being used is completely new, just introduced in the last few years. You know that viruses have genetic material like we do, and they make DNA and RNA. What we can do now, instead of growing the vaccine, we can synthesize, we can make the molecule of RNA or DNA. Once we have that genetic material of COVID, we can take it, inject it, or pulse it into your skin with an electrical pulse. Your body gets the RNA or gets the DNA, gets into the cell, and the cell sees nuclear material and starts to make protein that is of the virus. The COVID DNA or RNA is in your cell. Your cell now makes it. You don't have the virus, but your cell is making pieces of the virus, and that looks foreign. And your immunity cells come and say, oh, that's not normal. Let me make memory cells and fight it with antibodies. That means that you're now just like, oh, I haven't had the virus. But if I get the virus, I have memory to it and I immediately jump and attack it because I've seen pieces of it with that DNA and RNA. Now, the vaccines that are of that type are the Pfizer BioNTech that you've heard about, and the Moderna. And then there's a third one that's DNA type. So that is why that vaccine group, genetic material, has been the first to reach phase 3 large trials. I can synthesize the material quickly. I can inject you. I don't have to grow up the virus in chicken eggs, inactivate it, get enough together to vaccinate 30,000 people. It's the first one that's hit the market. And by the way, outstanding results. Neutralizing antibodies formed with both the Moderna and the Pfizer BioNTech. Very promising. It's why the United States government has paid over $1 billion to Moderna, over $1 billion to Pfizer. You know why? They said, start making us stuff. They asked for 100 million units of both before the phase 3 trials were over, because we want to be sure we have it in hand in the new year when we know it works. Now, the second grade of vaccines that were introduced that are really different, you could use genetic material and just inject it. You often need a booster for that to inject the genetic material again. And Tony Fauci talks about this. In the second type, you take the genetic material, you put it inside another virus, not a COVID virus. You put it inside another virus that you know has been inactivated, but can express the genes from COVID. The virus that they are using is called adenovirus. Adenovirus causes pink eye, causes a lot of different human infections. There are many serologies of adenovirus. I worked personally with adenovirus in the late 80s. We were going to do gene therapy with it. Maybe you remember that. You take a virus, put the normal gene in, inject it into the patient. You correct their genetic defect. Well, this strategy is you take a piece of the material of COVID, you put it in the adenovirus. Adenovirus infects the arm where you inject it. It's disabled, but it makes that protein. It makes the protein of COVID. Again, the body sees it, always the same pathway. Memory cells are induced. And then you don't get sick with COVID. But when you see COVID, you're resistant. And your body's memory cells come up and say, I've seen that protein before, and I'm going to attack it. Now, the virus, adenovirus, that is being used, you've heard about these, Johnson & Johnson and the AstraZeneca trial with Oxford, correct? Those both are using adenovirus. Adenovirus with the Oxford AstraZeneca group was doing a large phase 3 trial. Johnson & Johnson, I believe, was using a human adenovirus of a different serology. for large clinical trials. Now, one of the things about adenovirus is they do infect human hosts. The chimpanzee one doesn't. But adenoviruses in general, sometimes you can get sick from them, and the immune response can be excessive. And in both those trials, there were adverse effects. That's what you're talking about. And the FDA in the United States halted the Oxford AstraZeneca trial. It is still continuing around the world. And I heard about the Johnson & Johnson one. Was it today? Was it this morning? Yeah. And I haven't read the details of that. But with the AstraZeneca Oxford trial, it was a transverse myelitis, which is an inflammation of the neurons in the backbone, and it causes weakness, of the legs, and so that's a bad side effect, right? So those viruses are the group 2 that were both now adverse events that you might personally, if you're thinking about taking a vaccine, would you want number 1 or number 2? Well, there's a number 3 too. Number 3 is a different kind of vaccine, also pretty novel, that came out of all the technology, all the hard work of all the scientists over the last 10 years. All these technologies, by the way, are over the last 10 to 20 years, didn't exist before the 80s and 90s. So option 3 for a vaccine is, okay, we tried putting in DNA, RNA, that's genetic material. We tried putting parts of the material in another virus to deliver it. And part 3 is, why don't we just give you the protein? Why do we have to wait for your cell to make it? Why do we have to infect you? Why don't we just take a little piece of the COVID protein and inject it? Problem is your body's pretty good at breaking down proteins. It doesn't present it as foreign material. So what they've done is they've come up with unique nanoparticles for delivering the protein. And sometimes it's not even a protein. It's a bunch of small peptides, just a few amino acids linked together. And when you do that, if it's in a nanoparticle that allows it to get into a cell, suddenly you are seeing it as something's in me, something's not right, this isn't me, I need to go there and check it out, and then develop immunity, memory. Again, when I see COVID and those peptides or proteins are part of COVID, I remember it, let me attack it. Okay, so that's option 3. Option 4 is the stand alone, usual, grow it up in an egg and inactivate it and inject it into your arm like the flu vaccine. And that actually the Chinese have done with their viral vaccine. I think it's Sinopharm. Please check me on that. Don't quote me, but it's out of Wuhan, ironically. It's out of Wuhan. And I hear it's quite effective, but you would expect it to be. And remember, the Chinese had a big jump start on us because it started there, right? So they immediately started on this classical way of bad virus, let's grow it up. And they isolated the virus first too. So once you isolate the virus, you can then grow it. And then they started this inactivation and the vaccination trials. And I think they're in the Middle East with trials from the Chinese vaccine. Again, I think it's Sinopharm. I heard it's very effective, but again, you would expect it to be. So all of these are in early to late phase trials. There are new ones popping up all the time. There are always risks, even with a traditional vaccine. You've heard of swine flu, right? So you have Guillain-Barré. You have all kinds of side effects that occur when you trigger the human being's host response. And I think all of these are interesting technologies. Again, a real success of science. I think all 4 types, certainly type 1, 3, and 4, will be available to us early in the new year. And probably for a lot of the world, the group 2 with the adenoviruses. Although again, I think the FDA is very cautious in the United States, and at least as far as I knew today, they had halted the Oxford, AstraZeneca, and the J&J one, pretty sure.